Now in class 12th, I will tell you the applications of Wheatstone bridge. There are two applications, the post office box, the PO box, and second the meter bridge. Both are the practical application. And with the help of this we calculate the unknown resistance. So Wheatstone bridge application is to find out the unknown resistance. Wheatstone bridge is used to find out the unknown resistance. So what we have, we are having this P upon Q equal to R upon S. So, or this S equal to Q upon P into R. This formula is used. Now here P, Q, R, S are the four resistors. If three of them are given, then you can calculate the value of the fourth resistance or the fourth one. So either of three are given, then you can find the remaining resistance. Now here I have told you that this P and Q, these arms are called the ratio arms. The arm containing the resistance R is called the resistance arm, and the arm CD, that is called the unknown resistance arm. So unknown resistance is always applied in the CD side of the coordinator. So if we know the value of Q, P and R, then we can calculate the value of S. So it has two applications. First is I am telling you here, this is now post office box. Post office box. It is based on principle of Wheatstone bridge. So post office name is given because initially this was used to calculate the damage or the location of the broken wire of the telephone in the post office. Initially, post office and that the telephone was a single department called the P&T department. P means the post office, T means the telegram or the telephone department, but now they are separate from each other. The post office is one and that the telephone that is given to the another department, that is nowadays it is called the BSNL, somewhere this MTNL, like that. So this post office box was used in the post office to locate the damage or to locate the position of the broken telephone line. It was used in P&T department to find out the damage or broken telephone transmission line. So it was called named post office box. इसीलिए हम इसको पोस्ट ऑफिस बॉक्स कहते थे. It measures the resistance between 1 ohm to 10,000 ओम. 1 ओम और 10,000 ओम तक का हम माप सकते हैं, बट वेरी हाई एंड वेरी लो रेजिस्टेंस कैन नॉट बी मेजर्ड बाय दिस ओम. वेरी लो और वेरी हाई रेजिस्टेंस cannot be measured. By PO box. So now this is like this one. I am making you a rough diagram of the post office box. I am trying to make here we have a screw. Here like this, then we are having to this one. Here the resistance is of 1 ohm, then the different resistances are there. And then so many are there. then to this I have made a rough diagram of resistances. This is now your 1 ohm. This is your 10 ohm. This is 100 ohm. Similarly here on this side, this is 1 ohm, this is 10 ohm, this is 100 ohm, like this. This is now from 1 ohm, this is now your 2 ohm, this is now your 2 ohm, and then this goes at last. This is now your 10,000. 10 is to the power 4 ohm. Like this, we are having a number of resistances. So, this is the point, your P. This is now your A, we take it A. This is now point A. A. This is B. This is now your C, that will come here. And this is now your D. No, this is not like this. This we are taking to this is the point A, this is now B, this is now your C. This is now point C. And this is now point D. This is now point D. So AB, this is now resistance P. So much. This is now your Q. And this resistance is R. This is now R. Then this CD. CD is given to here. This is now S. Now then we are having the taking key. This is now your taking key. This is now key K1, and similarly this point your B. A and C, A and C. This is given another point to be connected. Here we are having this key. So this A from here and C here. So C to this one. Then AC we apply the battery. AC the battery. ABC, AC battery, and BD, D. This is here. This is like this. This is now key K2. These are taken keys. So A and C. This is now your C. Then we connect. positive and negative, and then B and D. So B from here and D from here. D from here. So this we are having a galvanometer. This is now like this. B now from here and D from here. This is all about the circuit of this post office box. This is arm P, this is arm Q, this is now arm R containing resistance from 1 to 10,000 ohm. This is like this one. And they are different resistances. Here we have used two like this. This is now you. Here we are having this resistance, this is now resistance. This is brass cap. Brass cap. So when this cap is removed, the current passes through the resistance. When this cap is inserted, then current does not pass through the resistance and it goes directly, because the resistance of this brass is very less in comparison to resistance. So it directly passes through this one. BT इसको ऐसे कर रहे हैं, उससे क्या होगा? Post office box. It is a sensitive device. More sensitive when P ratio Q is equal to 1 ratio 1. So one resistance is taken from each of them. So we have this, suppose the formula. This I take now, this suppose P, this is I take here the Q, this I take here the R, this is now your S, and then inference. This is the table. Now let here this P is equal to 1 ohm, Q equal to 1 ohm, then this R. Suppose this R we are getting to this 2 and 3. Let for 2 ohm. Here we take the deflection. Deflection in galvanometer. This is now, suppose you take, we now take 3 ohm. Here we get the deflection towards left and here towards right. It means that the resistance S is greater than 2 but less than 3. And now suppose we are given to this the same one, 1 ohm. this scenario. So we use S equal to Q upon P into R. So Q is given 1 ohm, this is now suppose given now 10 ohm. 10 ohm. This is you suppose this is now 24, this is now 25. Here we are getting it to be now deflection towards left, deflection towards right. So this S is how much? S is greater than 2.4 and less than 2.5. तो हम ये फॉर्मूला लगा करके इसको यहाँ निकाल देते हैं। लेफ्ट की तरफ आ रहा है डिफ्लेक्शन, तो राइट की तरफ आ रहा है। इसका मतलब ये कि एस का मान लेफ्ट और राइट इनमें से इन दोनों के बीच में कहीं होना चाहिए। And now suppose this we given the 100 ohm. This is now you suppose now it's 1 ohm. This is kept constant always. And then we take out the resistance from this resistance R. Let this is now your 242. This is towards now left. Then suppose 243. This is now deflection is 0. And then this is now 244. This is now suppose deflection 0. 245. Let this is now right. Deflection is towards right. It means this is the balanced position of this. So this value of S is equal to 2.43 plus 2.44 upon 2. So far we are having 2 or more than 2 resistances for which the deflection in the calorimeter is 0. Then in that case we take the average of this one for which the deflection is 0. Then this will be the resistance. So this you can get, this is now your 7, this is now your 8 plus 4 upon 2. So this is now your 2.435. So much more. This is what about the resistance. This is now resistance. When we know the resistance, we can find out the length of the broken wire or of the transmission line. The specific resistance. Resistance of unknown resistance. Let this is equal to now rho. So what we have? We can use so this rho equal to S into pi r square upon L. R the radius, where r equal to radius of wire and L equal to length of wire. So L equal to rho S into pi r square upon rho. Rho that is known to us. Rho is known, and by calculating the length L using AO formula. It will give the length of broken or damaged telephone ट्रांसमिशन लाइन। तो इसमें क्या होता है, जैसे ट्रांसमिशन लाइन काफ़ी लंबी जाती है, कई किलोमीटर तक होती है। तो सपोज करो कहीं तार टूट गया इसका, तो क्या होता है, तार टूट करके अर्थ में आ जाता है। यहाँ पर पोस्ट ऑफिस में भी हम क्या करते हैं, जो अननोन वायर होता है उस अननोन वायर को हम अर्थ कर देते हैं। तो अननोन वायर को अर्थ करने पर क्या होता है कि जो ऊपर का जो वायर होता है जहाँ से टूटा हुआ है, तो ये यहाँ पर अर्थ है, ये यहाँ पर अर्थ है, तो इसका मतलब ये जो वायर है वो अर्थ में आ जाता है। अर्थ में आते ही हम उसका रेजिस्टेंस मालूम कर लेते हैं कितना होता है। तो ये रेजिस्टेंस एस तो हमें इससे ज्ञात होता है, पोस्ट ऑफिस बॉक्स से ज्ञात होता है। एस हम जानते हैं पोस्ट ऑफिस बॉक्स से कितना होता है, ये अपन को पहले से नोन होता है, रेडियस कितनी होता है, पाई आर स्क्वायर कैलकुलेट करके रखते हैं। रो का मान अपन जानते हैं, अभी इतनी वैल्यू इसकी रो की, तो इससे हम एल का मान निकाल लेते हैं। तो एल का मान, when you find the value of L, then we can find that the wire is broken or damaged at so much length, and by that we can just eliminate the damaged wire, and then, or this is the repaired by some means, or the another wire is applied on the damaged wire. Because the transmission line is very long, so this is not possible to go along the line and then find that where is the damage. So by using the post office box, we calculate that the wire is broken at a distance of 1 kilometer, 1.5 kilometer, or this is not 10 kilometer, and then the people go there and they repair the transmission line. In this way, we can repair the transmission line by using this post office box, by finding the length of the wire. So this is how the post office box is used in the PNT department to find the location of the damaged transmission line. Now in the next lecture, I will tell you about the meter bridge. All these are the post office box and meter bridge. They are the practical purpose instruments based on Wheatstone bridge. So thank you very much.